Let us look at proposition number 34 of works of Archimedes, specifically from book 1 of On the Sphere and Cylinder. The proposition says any sphere is equal to 4 times the cone which has its base equal to the greatest circle in the sphere and its height equal to the radius of the sphere. So let's take it step by step. Given a sphere with a great circle A prime M. Now V be a cone whose base is equal to 4 times the great circle and height equal to radius of the sphere. What the proposition is saying is that the volume of the sphere will be equal to the volume of this cone. Now to prove this, we will use proof by contradiction. So we will assume that sphere is not equal to cone P. That means the sphere is going to be either less than or greater than the cone V. That is the volumes. So let's take it one by one. Case 1, sphere is greater than cone V. Since we have assumed that sphere is greater than cone V, that means we can find two straight lines beta and gamma such that beta is greater than gamma and beta is to gamma is less than the volume of the sphere is to the cone V. And how to do this we have seen in proposition 2. Now let delta and epsilon be two arithmetic means. Circumscribe and inscribe similar regular polygons with sides 4n in and about the great circle such that AB is to AB. Remember, AB is the side of the circumscribed polygon and lowercase ab is the side of the inscribed polygon. So we have to circumscribe and inscribe similar regular polygons with sides which are multiple of 4 and about the great circle such that AB is to AB is less than beta is to delta. Now volume of circumscribed solid is to volume of inscribed solid is equal to the triplicate ratio of the sides. Again, previous proposition. Now that means volume of circumscribed solid is to volume of inscribed solid is going to be less than beta cube is to delta cube. Since we have constructed these solids such that AB is to AB is less than beta is to delta. So which means if the solids are in this triplicate ratio of AB and AB, then they will be less than beta cube is to delta cube. Remember, beta, delta, epsilon and gamma are in continued proportion. So that means if we say beta cube is to delta cube, that means beta is to gamma. They will be equal to each other. Now, volume of circumscribed solid is to volume of inscribed solid is less than volume of sphere is to cone V, because beta is to gamma is less than volume of sphere is to V. Let's put it in this form. Is this relationship possible? That the ratio between these solids is less than the volume of sphere is to cone V. Volume of circumscribed solid is greater than volume of sphere. We have seen this. And volume of inscribed solid has to be greater than the volume of the cone V for this relationship to be valid, for this ratio to be less than this ratio. Volume of inscribed solid is not greater than volume of cone P. So that means this is not possible and therefore sphere is not greater than cone V. So one possibility gone. Now let's look at the other possibility. Sphere is less than cone V. Again, we repeat the entire process. Find two straight lines beta and gamma such that beta is greater than gamma and beta is to gamma is less than V is to cone V is to volume of sphere. Now in the previous case, we had said volume of sphere is to V, whereas here it is V is to volume of sphere. And 2, arithmetic means delta and epsilon. And then circumscribe and inscribe similar regular polygons with sides 4n in and about the great circle such that AB is to AB is less than beta is to delta. Now we know that volume of circumscribed solid is to volume of inscribed solid is in triplicate ratio of the corresponding sides. That is AB cube is to AB cube. And since AB is to AB is less than beta is to delta, that means volume of circumscribed solid is to volume of inscribed solid is less than beta cube is to delta cube. And since beta, delta, epsilon and gamma are in continued proportion, if beta cube is to delta cube we are looking at, then it is the same as beta is to gamma. Again, which means volume of circumscribed solid is to volume of inscribed solid is less than cone V is to volume of sphere. Because beta is to gamma is less than V is to volume of sphere. V here is cone V. So we are substituting beta is to gamma with cone V is to volume of sphere. Again, let's write it in this form. Now this is not possible because we know that the volume of inscribed solid is less than volume of the sphere. And volume of the circumscribed solid is greater than the volume of cone V. Actually, it is greater than 4 times the volume of cone V. So, which means that this is not possible. Since it is not possible, sphere is not less than cone V. And since sphere is neither less than nor greater than cone V, implies that sphere is equal to V. So we can say sphere is equal to a cone whose base is equal to 4 times a great circle and height is equal to the radius of the sphere. Now let's look at the corollary to proposition 34. The corollary says every cylinder whose base is the greatest circle in a sphere and whose height is equal to the diameter of the sphere is 3/2 of the sphere, and its surface together with its bases is 3/2 of the surface of the sphere. Very interesting. Let's look at it step by step. Given a sphere, draw a great circle on the sphere. Draw a cylinder with the great circle as the base and height equal to the diameter of the great circle. From Euclid, we know that the volume of a cylinder is equal to 3 times the cone or 3 times the volume of the cone with the same base and height. So volume of this cylinder is equal to 3 times the volume of this cone. Now, remember the height of the cylinder is equal to the diameter of the great circle. Now, if we convert it into radius, instead of taking the diameter, if we take it as the radius, then it is cylinder's volume will be equal to 6 times the cone with the same base and height equal to radius of the sphere. We also know that sphere is equal to 4 times a cone with base equal to great circle and height equal to radius of sphere. Cylinder is to sphere is equal to 6:4 because the cones are same. Here also the cone has the same base as the great circle and height equal to radius of sphere. Here also cone has a great circle as the base and height equal to radius of sphere. So volume of cylinder is to volume of sphere is equal to 6:4. We can write it as cylinder is equal to 6/4 of a sphere. Or if we simplify it, volume of a cylinder is equal to 3/2 of a volume of sphere, or 1.5 times the sphere. Pretty straightforward. But to be able to arrive at this result, we have to go through all the propositions in between previously we have looked at that allows us to come to this conclusion. Now, what about the surface area? Lateral surface of the cylinder, which means the bases are not equal, top and bottom are not included. So lateral surface of the cylinder is equal to a circle P whose radius is the mean proportional between the height of the cylinder and diameter of the base. In the cylinder under consideration, height is equal to the diameter of the base. So therefore, the circle P has a radius equal to diameter of the sphere, because diameter of the base is nothing but the great circle, diameter of the great circle, which is also the diameter of the sphere, or a circle equal to 4 times the great circle of the sphere. So the total surface area of the cylinder is equal to 6 times the great circle. So surface of the sphere is equal to 4 times the great circle. Again, we have already seen this. So that means the total surface of the cylinder is to surface of the sphere is equal to 6:4. That means total surface of the cylinder is equal to 6/4 of surface of the sphere, or 3/2 of surface of the sphere, or 1.5 times the surface of the sphere. That is proposition number 34 and its corollary from works of Archimedes, specifically from book 1 of On the Sphere and Cylinder. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now. Bye.